Well, thank you for joining us today for our November webinar. We're going to be taking a look at the Science Gateway Center of Excellence, Workforce Development, Faculty Curriculum Enhancement Model using the hackathon. And we'll just move on as quick as I can. We're going to take a overview of some of the outcomes of the model, and then a report from one of our past faculty participants. And then Elijah McCarthy from Oak Ridge National Lab will talk about the model itself, details of it from a paper that we just had presented at the International Conference on Games in Jan. And then we won Best Event Report. Yay. And finally, we'll look at what the future holds for us in terms of a long-range place of storing for these curriculum products. We want to share, point out that this has been under the sponsorship of some really great organizations and groups. Omnibond has been with us since the very, very beginning, loyal partner. Oak Ridge has provided invaluable mentoring for our faculty participants, and SGX3, of course. We've had support from US RISE, who's especially for this last RSE, especially for this last hackathon, and then some others who we couldn't have done this without. We've had 3 iterations of this model starting in 2022. Overall, we've had primarily computer science faculty members, and be involved, but we've had 3 from the natural sciences, 2 from engineering technology. We've had 2 accounting faculty members and 1 health and human services member. About 69% were male, and the remaining female. Many of them were from minority serving institutions as well. For a total of about 49 participants. I'm going to let Dr. Ekbari talk about his experience with our model now. So he has a commitment at 3. So Dr. Ekbari, I'll advance the slides if you want to. And that's Dr. Ekbari with his partner, Dr. Cheryl Bradford from ECSU. And they worked on a course called Data Mining and Machine Learning. And I'll advance the first slide for you. Dr. Ekbari.
Okay, I got it. So actually, the course is a computer science course. It's a data mining and machine learning course. We offer the course in the spring in the Department of Computer Science, Engineering Technology, and Mathematics. So the course actually covers the basics of data mining and analysis techniques. It provides a background and the knowledge on how to conduct data mining project. So the course starts by defining what knowledge discovery and data mining is. Within the data mining tasks such as classification, clustering, association analysis are discussed in detail. Also, in the course project, a student get hands-on experience in conducting data mining project, that's what I mean, and the data analysis, data and implementing and getting hands-on experience in project, including data analysis and data mining. Also, fundamentals of machine learning, such as a neural network and deep learning, are introduced for the student. Next slide, please.
Okay, next.
So one of the, actually, how I introduce HPC for the student, actually starting from when I reach to the clustering technique, like K-means the clustering technique, I introduce this technique, and from here I start introducing the HPC for the student. So actually, just to understand why I choose K-means the clustering technique, actually the technique here or the algorithm depends on trying to sort the data or the object in different clusters. And actually, we started the process or the sorting by assigning k centroids or number of centroids to the object in the data, or if it's an image, to the pixels. And then we calculate the distance between every pixels and every centroid. And then we assign the data or the object to the closest centroid. And then we keep doing that and updating again the centroid based on the assigned object for each cluster, and then I have to keep keep repeating the process several times until the algorithm converge and I come up with different clusters from the data. So actually, next slide, please. As you see here, the algorithm actually includes a for loop. And the for loop actually takes time depending on the number of iteration t's until the convergence. And also here, the number of the centroid keys, number of the object or the pixel, or what about whatever the type of the data, and here the d of the dimension of the data. So actually, by introducing this equation and introducing for the student or suggesting a solution for this to reduce the time by introducing parallelization for the student start to recognize the benefits from this new technology or high performance computing technology. So we can, instead of working with each centroid in a series fashion, why not I can work with all the centroids in parallel and get the job done quickly, very quickly. So from this, actually, I'm starting to introduce the student what is the HPC technology and also how we reach to them. And I introduce to them a course. Here, I give them this course here, and I assign to them a homework, and I ask them a feedback and reflection on what I assigned to them. And also, I work with them for a project on using Jupyter, and I'm working with them in a collaboration on a project, divided them to several groups, and I ask them each group can work collaboratively on using Jupyter Hub. And also, I'm introducing to them the science gateway. So by the end of the course, actually, that's a senior course, the student actually aware about what is the high performance computing technology, how they can reach them, how they can use them also in the training for the deep learning, especially if we have limited space, how we can utilize other facilities on the cloud to get train our models and test our model by using more resources from the overclouds. So this is a modification for the course, and I think the student actually, I get the feedback from them. The student actually, it's very useful. This module is useful for the student, and they have several takeaway from this modification for the regular course. Thank you.
Thank you. Thank you so much, Dr. Bari. So that was a look at one of the courses that we have had faculty redesign. Here's some of the others that were reported because this is a hybrid event. And so the first part is training and the actual course modification, which is virtually performed. And then we get together face-to-face at the Gateway Conference for the poster session. And here's some of the posters, the courses in computer forensics, introduction to cybersecurity, parallel computing courses, neural networks courses, general bioinformatics, homeland security courses have been modified, parallel algorithms classes, as well as fluid dynamic courses as well. A lot of good work. Now, as I said, we received the best report, event report at the 24th International Conference on Games and Jams. for our paper. And one of the authors, Elijah McCarthy, is going to give you an overview of that, which will also give you a better understanding of how we structure the Faculty Hackathon. I'll turn it over to you, Elijah.
Thank you, Dr. Hayden. Thank you. So I am Elijah McCarthy, an HPC engineer at the Oak Ridge Leadership Computing Facility. And I've been, since the inception of the Faculty Hackathon, we as Oak Ridge National Lab have been helping out, especially with getting mentors, technical mentors from the lab to help out with mentoring teams. So today I'm going to be talking about more about the mentoring aspect and the model as a whole. So with regards to the best event report that we had from the International Conference on Game Jams. So basically, we presented on the entire model, what necessitates dealing with something like Faculty Hack, why Faculty Hack is important, what it brings on the table. And so in this presentation, I'm going to summarize that. So yes, we can move on to the next slide. So one thing if you're a faculty on here or an industry person, even with the labs, one thing you'll notice is that both the NSF and the DOE are pushing on broadening participation, basically trying to ensure that there are more folks with diverse background in STEM fields. And so one of the things we felt would be very important to help bridge the gap that exists currently with regards to having diversity in STEM, even in HPC, even in other areas of science, is to equip the faculty so that they are able to kind of teach the students the techniques, the skills they need, so that they'll be marketable and be able to get into the fields of STEM, and so there'll be a variety of diversity in the field. And so that's the main goal, the main aim for Faculty Hack. And so for the Faculty Hackathon, currently faculties are unable to get resources that they might need with regards to revamping their courses, with regards to the resources they might need to have their students use HPC resources. And so during the Faculty Hackathon, one of the things that we do is to ensure that they are mentors, they are technical experts from different fields of HPC, of different fields of science, that can come and help partner with the faculty so that they can be able to revamp their courses to include HPC content. So here on this slide, we have two different faculties, two groups of faculties. On the bottom left, we have Dr. Watkins and Professor Yvonne Phillips from Morehouse College, a four-year college here in Atlanta. We have on the right another faculty from the 2024 cohort. And so basically this faculty participated in the hackathons, came in with courses that they wanted to have HPC content inculcated into, or courses that they wanted to revamp. For the 2022 cohort, where Dr. Watkins was a part of, their course was a data science course. And so you see diversity. It's not just anything computer science or computer engineering, but it's basically all diverse fields of science, just to kind of inculcate or include HPC into the content. Now, the model, how it works, we have participants that come in, the faculty that come in as hackers. We have mentors that can be from national labs, that can be from industry that has HPC expertise that come in to help provide resources to the faculty, point them to resources that will be helpful in their courses. We also have peer mentors. So faculty that have that started with the Faculty Hack, say the 2024 cohort or the 2023 cohort, come back as peer mentors, and they help out with the teams as well. We can move to the next slide. So I just talked about the participants, so faculty. We have the mentors that are coming, and there is a deliberate effort to ensure that the teams that are coming in are coming from MSIs, HBCUs, HSIs, so small liberal arts colleges, just to ensure that we are getting the right group of folks to ensure that the resources that are provided are going into the right hands, because where there is minority, where the minorities are, that's where we are aiming to target, to ensure that there's diversity when it comes into the field of HPC or even STEM as a whole. And so you see here on the slide that 76% of the institutions or of the faculty that are being a part of the hack coming from MSIs that have been categorized as HBCUs. Let's move on to the next slide.
Ooh, hold a minute.
Okay. Yes. So one other thing within the model, the faculty hack model, is so if you probably might have heard of Hack HPC, where they are students that are coming, they hack during a certain period of time, they are given projects, they are mentors mostly from academia or even from labs that are coming with projects, and then the students sign up as participants and they get on the projects that they feel are most suitable to of interest to them. Now, for those, for Hack HPC, the students get prizes because we have Viewer Choice Awards, we have Judges Choice Awards, and all those kind of awards. It's a competition, and so prizes are given to the students. But for Faculty Hack, with regards to insensitizing the faculty, so that there is the zeal, there is the passion to participate in this. There are honorariums that are given to the faculty at the end of the hack. They are also giving travel support in order to travel to gateways conferences, so they are able to network more and also be able to collaborate with folks outside their institutions. And so that's one way of insensitizing the faculty. The funds for this are coming from SGCI, the grants that it has for professional development. And so with regards to finances, that's where the funds are coming from. And the reason why these are being given to the faculty is to kind of insensitize them, but also to help out with travel when it comes to going to some of these conferences. We can move to the next slide. Okay, so key roles when it comes to Faculty Hack. So I've talked about the model. The model is so Faculty Hack as a whole is a combination of two words, faculty and hackathon. And basically, we have faculty coming in. They want to revamp their courses. They want to develop curriculum that includes HPC, so that they can produce students that are going onto the market field and will be able to get employed in good places. And so in order to do that, we need experts that will help the faculty to build those courses, experts that will provide resources, be it HPC supercomputers or clusters that will help the faculty and the students to be able to run their applications or their jobs on. So there are several pieces of this. The faculties as participants, the mentors that come in, the mentors can be from industry or from labs or whichever field, so long as they have the expertise in HPC or a related field. We have organizers and staff that ensure that every part of the program is working, be it launching websites, be it reaching out to people so that they can be folks enrolling, hearing about the faculty hack and enrolling on it. So these are all different roles that exist within the faculty hack, and that they are sponsors. Some of the sponsors provide resources like Omnibond, provide time on some of their resources for faculty to get on and experiment, be able to run some code, spin up clusters, and be able to do some work on there. We can move on to the next slide. So all these parts come together for the different roles that exist within the faculty hack. Okay. Okay, so how does what happens? How is the procedure? How are things put together for the faculty hack? So before the hack, there is a planning phase where the staff and the administrators come together, put together the logistics, number of faculty that are being expected for a particular cohort, the number of mentors that will be needed to help those faculties. And also say channels that will enable communication between the faculties and the experts or the mentors that would be on logistics with regards to Slack channels, Discord channels, and also putting together Zoom sessions where faculty coming before the hackathon to get trained on different techniques that are very useful or that will be helpful to them throughout the hackathon. Then there is the actual hack sessions that happens for now, because these are faculties and have classes, it's mostly in the evenings. But if it's something that falls during the weekend, definitely in the mornings and in the evenings as well. But when it comes to going to gateways to present the posters from the faculty hackathon, the faculty obviously they're in the mornings, attend all the sessions, so both morning and evening. Then there's a final presentation, and those are the posters that are presented at gateways. And one of the faculty hack cohorts, 2022, they actually won the best poster award at Gateways 2022. We'll get to that. I have a slide for that in a bit. We can move on to the next slide. Okay, so what are the deliverables? What are the outcomes? What are we expecting to get at the end of this faculty hack? Is it just a moment to come, faculties to come together and then just chat and that's it? No. So the aim of the faculty hack is to get the students to get employable skills within HPC, not just HPC, but whatever field they might be in. They are computational scientists. The problems they are solving now are pretty advanced, and they cannot do it on their personal computers. They get on supercomputers to do that. They are biologists. The problems they are solving are huger than their laptops. They cannot solve those using the laptops. They get on HPC classes, and so these skills are very important. These skills are very salient for the students to have, so that when they go out as biologists, when they go out as mathematicians, they are able to use the resources that are available to be able to accomplish their tasks. And so that's the main aim of the faculty hack. And so for in order to ensure that this has been done, there are a few things that we outlined for with regards to outcome from the faculty hack. One of them is having a revised course description, course outline that includes HPC content. Being associated or being paired with a mentor, so that there is that collaboration that exists between the faculty and the expert or the mentor. Then there's also the so I talked about the collaboration, and then there's obviously there are faculty that are coming from different institutions. You get to meet faculty that are doing teaching the same course as you, and in different settings, and so you get to collaborate on how best you can teach the students, how best you can include employable skills, HPC employable skills, whichever field employable skills, so that the students, when they get out, they are able to get employed. And so these are outcomes that we look for. They are itemized here in 5, and I've summarized those, but you can take a more detailed look at them later from the slides when they are available. We can move on to the next slide. Okay. So I'm quickly going through this because we have time restrictions, but over here, so there's professional development part of the faculty hack. After everything, the faculties go to the conferences, and over there you can think of it as a professional development for the faculty. There are different technologies, there are different inventions that are being discussed at the conferences, and so faculty get to know about those, get to know about cutting edge research work that folks in different places are doing. And it can also lead to collaborations between the faculty and researchers in different fields that come to the Gateways conference. So there is professional development in that regard. We can move on to the next slide. So there has been 3 cohorts of the Faculty Hackathon, 22, 23, 24 so far. And so what have we learned, and what do we think is there is room for improvement for? So, well, during the hackathons, we have one of the deliverables is that faculty come up with GitHub repos, and those repos, they are supposed to have their course descriptions, the resources that the mentors have pointed them to, and all that. But one thing we've noticed is that the GitHub repos that are created personally. Each group of faculty create their own personal repos. And so one thing we've noticed that will be helpful is that we have a centralized repo that say Faculty Hackathon repos, and then we create a branch of it every year for every cohort. And so when faculty for a particular team within a cohort, they can just fork a branch of that, and then be able to commit to it, and then we can merge everything into different branches. And so that will be a resource that subsequent years faculty that come in can be pointed to. It's not all scattered around, every faculty having their own repos that are personal to them, but it's centralized. And so it can be a resource we can share to faculty that want to revamp their courses by just going to that GitHub repository. We can move on to the next slide. So course evaluations. So one thing we've also identified is that the mentors coming, they help the faculty revamp the courses and all that, but then they do not get to know how the course implementation went. And it will be good to know how the course implementations went, so that when they have follow-ups or they have ideas to improve upon things, they can share those with the faculty. And so a way to kind of have evaluations of those courses, how they went, how the students received those, so that it can help build on the course. That's another thing we've identified to be a way we can improve on the hackathons. Now, the other thing is duration of the hackathons. Initially, for the 2023, for the 23 cohort, it was for a couple of days, just a weekend, Thursday, Friday, Saturday, and then it was over. And so we felt like the resources that might have been given to the faculty, they might not have had enough time to digest the resources, so that in case they have questions, they can reach out to the faculty. And so stretching this over quite a number of days, or maybe a week or two would be helpful. That way faculty have some time to process the resources, put together, and then if they feel like there are shortfalls, they can reach out to they have their mentors available, and then they can improve upon those. We can move on to the next slide. So faculty mentor programs. So we've had faculty, like I mentioned, from previous cohorts that have been a part of the hack. And so for subsequent cohorts, it will be helpful to have those faculty come back as peer mentors. That way they already know what worked for them in their classes, what resources the mentors give them, and so they can share these with the newer faculties that are coming in. Another thing is they are able to guide or share their experiences from their classes that they've already run with the newer faculties. And so that's one thing we feel will also be helpful. Then the next thing is guest lectures. So I think this is more in the ball court of the faculty. So they are mentors from different fields, labs, industry that have come in to help these teams, to help this faculty. Now they can establish collaborations, so that from time to time they can invite these experts to come over and probably a piece of a lecture, a guest lecture on different topics that might be of interest to the students. It can be how you can get employed afterwards, or possible places to look out for employment with the skills that you are getting from the class. They can also share internship opportunities, or if they are even hiring within their teams. So guest lectures from the experts that worked as mentors, help the faculty, would also be helpful in the long run. The next slide, I think that is. So professional development, I already summarized that. So basically, faculty go to these conferences, and they get to learn about new technologies. They get to meet new researchers, and they can collaborate on different research projects or things of interest to them. We can move on to the next slide. I think for time, I think that's about it for my end. Okay.
Yep.
Thank you.
All right. Good. Thank you so much. We also want to emphasize the fact that science gateways are important, an important component of what the faculty um, use when they modify their um, curriculum. And their posters have to show the science gateways that they were suggested to use by their mentors, suggested by their mentors to use and include in their courses. So it's not all HPC. It's also science gateways that are involved in these modifications as well. Charlie, I'm going to turn this over to you now. I'm going to
Yes,
stop.
ma'am. Let me
Um,
share my screen. So hey everyone. So currently I'm at a conference called Supercomputing, where we just presented our HPC Ed idea. Now that we're moving out of a pilot phase and we're moving into an implementation phase. So I'm kind of happy to say that one of the aspects that kind of drove this HPC Ed in the first place was some of our experiences that we've had with the faculty hack on trying to get material, trying to find material that the faculty can use to learn some of these new techniques, what techniques they want to learn on top of that, as well as finding experts in the field to be able to collaborate with, as Elijah had mentioned. So all that kind of gave forth to this idea, this HPC Ed. So I was going to talk a little bit about it, and then also talk a little bit about what the future collaboration between HPC Ed and the SGX3 faculty hack would look like. All right, so obviously there's a team of us involved with this HPC Ed. There's a team in front of you. Some of the names should be familiar. At the very least, one of the names should be familiar. But you should see like Jamie Powell's on here and myself are on here. And so this is our input from the HPC Ed world, or from the Science Gateways world. All right, so the main idea we've been doing is trying to scale HPC education. A lot of aspects of it, of course, like I said, drew from the faculty hack. So we understand what we're looking for and what we're trying to do. But the main idea is if you do a Google on a simple HPC concept like parallel programming or Python programming or data science, just a simple Google will give you millions of results. And the idea is you don't know exactly what's good, what's not. You can spend an entire hour, 2 hours, 3 hours looking at some of these resources and realize this is not what you're looking for. So HPC Ed decided, you know what, we're going to build this federated catalog, meaning it's not centralized. It's spread along lots of different institutions, lots of different data resources, a lot of different repositories that are all giving us metadata to be able to point to your specific training material. So the idea is trying to find these things. That was our goal, improving the material sharing and material discovery. We're doing this through this federated architecture, where we're collecting data sets from instructors, from professors, from institutes, and we're running hackathons, we're running workshops, and we're doing online training, and all this stuff is out there. The idea is trying to get it to you, the consumer. So essentially, we had to build a metadata, we had to build taxonomy, we had to understand what these existing taxonomies look like, and how do we apply it to, well, training material. And then being able to take that information, that taxonomy, that the training material that's been loaded and shared in a federated area, and then share that, and then publish that, and then use the FAIR principles, right? Findable, accessible, interoperable, and reusable. Apply that to the training material that we're using and implementing and sharing. And of course, that means you got to discover it. You got to find it somewhere. And you have to use these local science gateways to be able to connect to our federated catalog. And so we've opened up all these RESTful APIs that you can now connect to and search with and use and utilize. And then, of course, the joy of this is that since we are generating training material, we're using that training material in our classroom and we're sharing it with other people. A lot of times, this material has been peer reviewed. And so, first off, we have peer-reviewed training material that we're connecting to and is federated. And then we're also looking to see, well, what gets shared the most, what gets used the most, what are people actually selecting when they're teaching, like say, a introduction to Python class. And of course, giving community input through like a rating system that we've implemented as well. And then of course, using AI to also assist you in finding material that you're looking for, using AI to build the metadata so it accurately reflects what the catalog item is, and then putting it all together under one umbrella. And then, of course, we've been training and we've been looking for early adopters and getting their input to build the system with. We're looking for letters of commitment that you're wanting to use and work with us, being able to say that, hey, we're going to use the HPC Ed training system or catalog system, metadata system, and we're going to plug our training material in there. And that is exactly where HPC Ed, why we're growing as much as we are, and why we're trying to incorporate the faculty hack information in here, because the faculty hack is creating material. So you're essentially in this little category here as an educator and a curator. So you're putting your data in a local catalog already. So what we're doing is we're asking you to take that local catalog, give us your metadata that we can then connect to it, and then use this federated catalog to populate our HPC Ed portal that then researchers, scientists, and students and other consumers can then get to the material. And of course, us in this federated catalog that we're building, like I said, it came out of our faculty hack, the need that our faculty hack showed. So you're also here in this category, being a consumer of the material and information that's sitting on this portal. And of course, we're growing, right? So we're not just looking at maybe adding training material to this, but we're also looking at adding data sets to it. So let's be a little bit more flexible on what we're bringing in. So the metadata is not just describing the training data, but it's also describing the training material. It's also describing, well, people. So one of the places that we want to expand to as well is, and scale this thing up to, is not just have material in there, but also the possibility of having field experts that you can then talk to. Hey, you're designing a course using for cybersecurity. Yeah, here's a lot of great cybersecurity material that you might be able to use. But we also have cybersecurity experts that are sitting in our database as well that are gladly and more than happy to collaborate with you. So we are now in a pilot program. The pilot program's ending, and now we're launching a implementation plan. But at the end of the pilot program, we do have this beta of a search algorithm to be able to find training material that is what you're looking for. So if you went up there and you said, oh, I'm looking for Python and I'm a novice, what material do you have for me? It already has a bunch of material that's been preloaded into the system. So of course, future work. I already kind of mentioned what we're looking for. Future work means we're now going to expand to not just training material, but data sets. We're not going to just look at data sets, we're also going to looking at people. We're not just looking at people, but we're also looking at outreach opportunities to build awareness of this tool that you all can use. And then, of course, future ideas is running more hackathons and running more workshops, doing HPC Ed based projects to be able to find out, hey, what gaps exist in our catalog? What aren't we covering enough of? What people do we need to bring in? What experts are out there that we can expand to? And of course, what training sessions, what conferences might exist that this would be able to connect into. And of course, because everybody else is doing it, so are we, we're incorporating an LLM into the system. The LLM is going to have multiple capabilities. It's going to be able to build training playlists for your specific needs. I'm a Python guy. I want to expand into parallel and multi-threaded Python. What information do I need to know to be able to go into that world? So essentially, the LLM be able to guide you through a training system that's saying, hey, this is what you need to know about Python, and here's some Python stuff for you. This is what you need to know about parallel programming and HPC technologies, and give you some information background. And this is what you need to know how multi-threading operations work and what the behind the scenes look like. And this is how you apply multi-threading into Python. It'll build that story for you. Therefore, it'd be a great tool for our faculty hackers to use in the future cohorts. Well, of course, we're always looking for feedback. We're always looking for more information. So there are 2 QR tags in here. The one on the left with the dinosaur, that takes you to the HPC Ed URL, our search pilot. The one on the left, there we go. One on the left is with the dinosaur, takes you to our homepage. The one on the right takes you to a interest survey where we can kind of get to know you a little bit more, information on that we can use to essentially build a better product. All right. So that's HPC Ed in a nutshell. And that's essentially the future that we're going to try and get to. Cross your fingers that we'll be accepted for an implementation phase that we are applying for in January. All right. Thanks, everyone. I really appreciate you all's time. Really appreciate everybody's effort. And I see there's a bunch of former hackers from the Faculty Hack in here. So it's, of course, great to see you all again. All right. Thank you, Doc. Thanks for the time.
Thank you, Charlie.
I'm going to stop my share here.
Okay. And so we have looked to this partnership with HPC Ed to implement our recommendation for central repository of our resources and these products that our faculty are generating so they'll be available to a wider community. As Charlie mentioned, there are other faculties who have been on the in the program, the Faculty Hack program. I noticed Bernadette. Bernadette, you want to just say hello quickly?
Hello. I don't have much of a voice, sorry.
Yeah. And she's with Southern Oregon University?
That's right.
Okay. Are there any other faculty hackers on the line with us today? Let's see if I can look at the
Yeah, Wanjun's on.
Wanju? Okay. Say hello, Wanju.
Or we just wave at you.
Just wave at you. We'll just wave at you. Okay. And
okay, I'm
Oh, there
sorry.
you are.
Okay.
I
Say
mute
hello.
myself. Yeah. Yes.
All right.
Hi. I'm from Albany State University of Georgia.
All right.
I attended this year's hackathon. My advisor, Charlie, is over there, and
Yeah.
also Professor Lauren, right?
Yeah. Okay.
Yes.
And Donnie, you've been a mentor in the past. You want to just say hello? You got 1 minute. Sister?
Me? Not me. Okay.
So Donnie
Okay.
from Louisiana. Okay. He's not connecting. Well, I want to thank you for joining us today. Look forward to hearing from you if you get feedback from you. And I'm at lbhayden@ecsu.edu. If you would like to contact me, I'd be glad to hear from you. lbhayden@ecsu.edu. Thank you.